Hello everyone! Today we're uncovering the remarkable journey of the coconut, often hailed as the tree of life thanks to its abundant uses. From refreshingly sweet coconut water and nutritious flesh to versatile husks and shells, every part of this tropical wonder offers diverse applications in food, fuel, fiber, and more. But how are these massive nuts grown, harvested, and processed to yield such an extensive range of sustainable treasures? Join us as we delve into the entire process, from sun-drenched coconut farms to the high-tech factories that transform coconuts into products cherished worldwide. Trust me, if your morning coffee had a travel diary like this coconut, you'd never sip it the same way again. Coconuts are grown in over 90 tropical nations, with major producers like Indonesia, the Philippines, India, Sri Lanka, and parts of Africa and Latin America. Their adaptability and multi-purpose nature make them a cornerstone of local economies, supplying jobs, food security, and export earnings. Meanwhile, global markets prize coconut-based products for their perceived health benefits and wide-ranging uses. Coconut oil, milk, coir fiber, activated charcoal, and more. Beyond commerce, coconuts hold cultural importance, featured in traditional cuisine, medicine, and rituals. This blend of economic and cultural value means coconut cultivation remains a vital pursuit in many coastal and island communities. Take, for instance, a cultural festival in Kerala, India, where coconuts are ceremonially broken at the start of important events. Families across South India also incorporate coconut into almost every meal, whether as grated flesh in curries or coconut milk in sweet desserts, showcasing just how deeply rooted the fruit is in daily life and tradition. Coconut palms thrive in warm, humid climates, generally within 25 degrees north or south of the equator. They love sandy or loamy soils with ample rainfall and moderate salinity tolerance. Farmers typically plant seedlings or sprouted nuts, spacing them so the broad crowns receive full sunlight. Once established, a coconut tree can produce nuts year-round, though fruiting can peak during certain seasons. It can take 6 to 10 years for a palm to become fully productive. Maintaining soil fertility via compost, mulch, or organic manure helps ensure consistent yields. Strategic irrigation systems may also be used in drier regions to counter water stress. Consider a medium-sized farm in Sri Lanka, where a farmer named Priyanka carefully tends to her newly planted coconut seedlings. She uses organic compost made from kitchen waste and dried leaves to enrich the soil around each sapling. During particularly dry spells, she sets up a simple drip irrigation system. This ensures that even under the scorching sun, the young palms receive just enough moisture to keep growing steadily. When coconuts reach maturity, roughly 10 to 12 months after flowering, they contain maximum water and copra, flesh. In many areas, skilled climbers scale the tall palms barefoot, using loops or belts to secure themselves while knocking down ripe coconuts with a sharp tool. Some plantations employ trained monkeys, though this practice faces controversy, while mechanized lifts or long poles are alternatives on commercial farms. Harvest frequency varies. Some farmers collect nuts every 45 to 60 days. Ensuring worker safety is critical, as falls from palm trees pose risks. Protective gear, stable climbing techniques, and trained teams help mitigate such hazards. Once gathered, coconuts are piled or loaded onto trucks for transport to processing centers. In certain modern plantations in Thailand, hydraulic lifts are increasingly common. Workers stand on small platforms that can be raised to the treetops, significantly reducing the chance of accidents. This shift represents how technology can enhance both productivity and safety, especially on larger farms. Often, initial husking occurs on site. Workers anchor a metal spike into the ground, then impale each coconut to peel away the tough outer husk. This step exposes the round, fibrous shell known as the endocarp. Dehusked nuts may be sold fresh or moved to factories for further processing. Some farms or small cooperatives also produce partial products at this stage, like coconut husk fiber, coir, used for ropes, mats, or peat substitutes in gardening. Coir extraction entails beating or soaking husks to release fibers, then drying and bundling them for sale. Farms may bundle husks separately or pass them to coir mills, ensuring minimal waste. On a small family-run farm in Indonesia, the adults husk coconuts, while children help collect the discarded husks in piles. Later, these are sent to a nearby coir mill, where local women work on mechanical defibrillators that efficiently separate long fibers from the husk. This cooperation not only supports the farm, but also provides additional livelihood for the surrounding community. Large-scale coconut factories require a steady supply of nuts to meet production demands. Trucks or boats ferry coconuts from farms, sometimes over great distances, maintaining dryness to prevent mold. On arrival, each batch may undergo weight checks, moisture readings, and visual inspection. Basic grading separates premium nuts destined for fresh coconut water or specialized markets from standard ones for copra, oil extraction, or desiccated coconut production. Technology can assist here. Factories may use optical scanners or conveyor-based sorting. However, in many places, human labor remains the norm, with workers quickly discerning quality by tapping or examining shell color and dryness. In some remote island communities in the South Pacific, boats packed with coconuts are a common sight. The coconuts are transferred to larger cargo vessels, which then journey to mainland processing plants. Throughout this transport chain, tarps or simple overhead covers help shield the coconuts from rain and sea spray, reducing the risk of premature spoilage. Coconuts can be transformed into a host of products. 3 key routes include coconut water and flesh. For drinks or culinary use, factories crack open fresh nuts, drain the water, and scoop out the soft flesh, often using specialized machinery. The water is filtered, pasteurized, and bottled, while the flesh can be shredded or turned into coconut milk and cream. Copra and oil extraction. Nuts intended for oil are split and dried, producing copra, the dried kernel. This copra is then pressed or solvent extracted to yield coconut oil used in cooking, cosmetics, or soap manufacturing. Coir and other byproducts. Husks yield coir fiber for ropes, mats, and geotextiles. Shells can be turned into charcoal or activated carbon. Even the leftover water or organic waste can feed biogas plants, supporting energy needs. Let's look at each path more closely. Picture a larger processing complex in India that handles all 3 routes under one roof. One section features a state-of-the-art coconut water bottling line, while another building focuses on drying and pressing copra for oil. In yet another corner, husks are pulverized to extract coir fiber. Every byproduct is utilized, demonstrating how nothing goes to waste in a well-coordinated coconut operation. For coconut water, machines carefully perforate the shell at the eye, or create a small hole to drain the liquid into hygienic collection tanks. Since raw coconut water is highly perishable, it's often pasteurized or microfiltered to extend shelf life. Some high-tech lines rely on UHT, ultra-high temperature processes, ensuring a stable product without refrigeration. Coconut meat for fresh coconut markets may be scooped or peeled using mechanical tools. The resulting white flesh can be sold as chunks, grated or processed into coconut milk by grinding and pressing with water. Coconut milk is then packaged in cans or cartons, frequently homogenized to keep fat from separating. In certain factories in Brazil, you'll see workers wearing hairnets and gloves, operating specialized cracking stations. Once coconuts are cracked, the refreshing water flows into stainless steel collection basins. After filtration and pasteurization, it's bottled into bright, tropical-themed packaging that appeals to both local and international customers seeking a taste of summer all year round. Copra making remains crucial for oil extraction. Factories or cooperatives split coconuts in half, removing any residual husk or fiber. They then dry the halves in kilns, sun-drying racks, or hot air chambers. Traditional sun-drying can take days and risk spoilage in humid weather, while modern hot air units accelerate the process more reliably. As moisture content drops, the kernel shrinks away from the shell, forming copra, hard and brownish. Quality hinges on dryness levels of around 6 to 7%, ensuring mold-free storage. Copra is typically bagged and stored until oil extraction commences. On smaller family farms, copra production might still rely heavily on sun-drying. Families often place coconut halves on large bamboo racks out in the open. Every few hours, someone rotates the nuts to make sure they dry evenly. During monsoon season, they might shift to a basic wood-fired kiln setup in a shed, helping them continue production even when the weather is less predictable. Mechanical expeller. Pressing. Copra is ground into small flakes and fed into a screw press. Pressure and friction extract the oil, which drains out while the pressed cake is ejected. This yields crude coconut oil, which may require refining. Solvent extraction. For maximum oil recovery, some facilities treat pressed cake or copra with solvents, often hexane. The solvent oil mixture is separated and the solvent is distilled off for reuse. Residual meal becomes animal feed. Virgin coconut oil, VCO, produced from fresh coconut meat rather than copra. Milk is extracted and centrifuged or fermented to separate oil. This method retains more coconut aroma and nutrients, commanding a premium price but at lower yields. Post-extraction, oil can undergo refining steps, degumming, bleaching, and deodorizing if a neutral taste and clarity are desired. In a high-tech facility in Malaysia, you might see towering steel tanks where centrifugation occurs. Here, fresh coconut milk is spun at high speeds, allowing the lighter oil to separate naturally. Workers in lab coats monitor the entire process through digital controls, ensuring each batch meets purity standards and captures that signature tropical fragrance. Coconut husks house coir fiber, the outer layer, and pith, the spongy interior. Coir factories soak husks in water to soften them, called retting, or pass them through defibrillator machines that shred the husks. Separation yields long bristle fibers and shorter mattress fibers, each used in distinct products. Fibers are washed, dried, and baled. They can be spun into rope or twine, woven into mats or nets, or used in upholstery. Meanwhile, coir pith, often called cocoa peat, is a popular soil amendment, lightweight, water retentive, and eco-friendly compared to peat moss. Factories compress pith into bricks or blocks for horticulture markets worldwide. In an eco-friendly gardening shop in Germany, You may find neatly packaged cocoa peat bricks labeled as a sustainable alternative to traditional peat moss. Home gardeners simply soak the brick in water, watch it expand dramatically, and then use the fluffy material to improve soil structure in potted plants or garden beds. Leftover coconut shells find use in charcoal production. Shells are heated in low-oxygen kilns to create coconut charcoal, denser and cleaner burning than wood charcoal. This charcoal can be sold directly for grilling or further processed into activated carbon via steam or chemical activation. Activated carbon from coconut shells is prized for its high absorption capacity in water purification, air filters, and industrial applications. Factories that produce large volumes of charcoal or activated carbon often integrate advanced emission control systems to minimize environmental impact, turning coconut waste into valuable resources. Imagine a modern production line in Vietnam. Coconut shells are loaded onto conveyor belts leading to large, rotating kilns. Sensors monitor oxygen levels and temperature, ensuring the shells turn into high-quality charcoal without excessive smoke. The finished product is then packaged into briquettes for export, some heading to restaurants in Europe for gourmet grilling, while a portion is further treated to become activated carbon for water filtration systems in hospitals. Factories maintain stringent standards, especially for edible products. Lab techs test coconut water or oil for microbial contamination, pH, rancidity markers, and heavy metals. For coconut milk or cream, consistency, fat content, and stability are checked. Meanwhile, coir fiber batches might be graded for fiber length, impurities, or moisture, HACCP, hazard analysis and critical control points, ISO certifications, and local food safety laws guide production lines. With coconut's rising popularity in global health-conscious markets, ensuring purity and traceability cements a brand's reliability. At a large coconut water bottling plant in the Dominican Republic, technicians in sterile lab coats regularly pull samples off the conveyor belt to test in on-site labs. They look for any off flavors, bacteria, or changes in acidity. These rigorous checks bolster consumer confidence, helping the brand expand to premium supermarkets across North America and Europe. Coconut-based goods appear in numerous forms: Tetra packs for coconut water, cans for coconut milk, jars or pouches for coconut oil, or bricks for coir pith. Factories handle high-speed bottling or canning lines, labeling each product with brand designs, nutritional facts, and certifications, RSAG, organic, fair trade. Brands often highlight coconut's tropical origin, sustainability claims like smallholder farmer support, or health benefits. This marketing resonates with consumers drawn to the exotic aura of coconut, whether it's for dairy-free diets, natural skincare, or robust cooking oil. In a bustling trade expo in Dubai, coconut products from Southeast Asia line the booths, boasting vibrant packaging with palm tree silhouettes. Some products emphasize their origin, like Island Fresh, Pure Sri Lankan, or Philippine Harvest, to differentiate themselves on international shelves. Many buyers from around the world stop by, intrigued by the promise of organic, ethically sourced coconut goods. In producing countries, coconuts saturate local markets. Families use fresh coconut flesh in dishes or coconut oil for frying. Export markets, however, see strong demand for specialized items like virgin coconut oil, coconut milk, or coconut water. Coir and activated carbon also play roles in international horticulture and industrial sectors. Shipping these products worldwide entails careful logistics, especially for perishable coconut water or milk. Temperature control during transport is key, while oils and dried goods enjoy simpler, more stable shipping conditions. In a large port in Java, Indonesia, containers packed with coconut milk cartons await loading onto cargo ships bound for Europe. Workers use refrigerated containers, reefers, to keep the milk cool and preserve its freshness. Meanwhile, nearby containers filled with dried coir bricks can travel without refrigeration, making transport simpler and more cost-effective for that particular product line. Coconut processing epitomizes zero-waste principles. Each part, from husk to shell to flesh, offers distinct commercial avenues, fostering a circular system. Waste husks can become coir or biofuel. Leftover cake from oil pressing becomes animal feed, and coconut water byproducts fertilize fields or fuel biogas plants. Environmentally, coconut palm cultivation can be less resource-intensive than some other crops, though challenges remain regarding biodiversity and monoculture. Nonetheless, the potential for integrated minimal waste production appeals to eco-conscious consumers and aligns with global sustainability goals. Some modern plantations integrate solar power to run small processing facilities on-site. They utilize leftover coconut shells as biomass for heating, turning what was once waste into a practical energy source. These innovations show how coconut farms can evolve into fully sustainable ecosystems, benefiting both the environment and local communities. As demand for coconut products grows, factories adopt modern equipment to boost efficiency and maintain consistency. Automated coconut water extraction lines, high-speed husk defibrillators, or multi-stage oil refining units illustrate technological leaps. Some use advanced sensors or computerized controls to refine temperature settings or moisture levels. R&D teams develop new uses for coconut derivatives like coconut flour for gluten-free baking or coconut sugar from sap. Meanwhile, improved packaging solutions extend shelf life for fresh coconut water. These innovations keep the industry dynamic and competitive. A cutting-edge research facility in Singapore might focus on perfecting coconut sugar processing methods. They experiment with vacuum evaporators that gently remove water from coconut sap at lower temperatures, preserving more nutrients and yielding a rich, caramel-like sweetener. These breakthroughs help coconut farmers tap into new, lucrative markets. Coconuts resonate with health-conscious trends, seen as a natural source of electrolytes, healthy fats, and micronutrients. Coconut oil is debated for its saturated fat content, yet many appreciate its unique flavor and potential benefits in moderation. Coconut water is prized for hydration and sports recovery. Coir-based mediums help organic gardeners cultivate chemical-free produce. Although some claims around coconut superfood status lack complete scientific backing, the general shift toward plant-based, minimally processed products continues fueling demand. Health and fitness influencers often post smoothie recipes featuring coconut milk or water, touting them as refreshing, natural alternatives to dairy-based drinks. Marathon runners sometimes carry small Tetra Pak coconut waters during training sessions, praising the lightly sweet taste and electrolyte boost without the additives found in many sports drinks. In many regions, small-scale farmers produce coconuts, collaborating via co-ops to pool resources and negotiate better prices. Fair trade or direct trade models ensure a portion of profits return to growers, funding community development or fair labor conditions. Factories often partner with these co-ops for stable supplies and ethically aligned branding. Support from NGOs and governments further fosters sustainable coconut production, training farmers in best practices, replanting aging palms, or diversifying crops under coconut canopies. In a remote area of Mindanao in the Philippines, a fair trade cooperative invests in a new water filtration system for the entire village, paid for by premiums earned on their certified organic coconuts. This infrastructure upgrade not only boosts hygiene and health standards, but also encourages more farmers to join the co-op, strengthening the local coconut industry's overall resilience. Coconut palms face aging trees, pests like rhinoceros beetles, and climate change impacts, drought, cyclones, salinity changes. Rejuvenation programs encourage planting new, disease-resistant varieties. Meanwhile, continuous improvement in post-harvest technology lessens spoilage and raises product quality. As global taste for coconut products continues, the industry must balance expansion with responsible farming, fair wages, and ecological stewardship. Potential breakthroughs in coconut genetics or ultra-efficient extraction methods could shape the next wave of coconut innovation. Scientists at an agricultural institute in Hawaii experiment with crossbreeding coconut varieties to develop more pest-resistant strains. They also analyze the palm's root structures to see which types can handle saltier soils, giving hope to coastal regions threatened by rising sea levels. From a steamy tropic orchard to factory lines meticulously extracting every drop of value, the coconut's journey is a testament to nature's generosity. Each part, husk, shell, water, flesh, transforms into everyday products that nourish people, power industries, and even enrich gardens. So next time you sip refreshing coconut water, fry with coconut oil, or walk on a coir mat, remember the intricate chain of farming, engineering, and care behind that simple, versatile fruit. If you've enjoyed this deep dive, consider subscribing for more explorations of how global agricultural miracles become staples in our homes. Feel free to share your favorite coconut-based product or recipe in the comments. Whether it's a silky curry, a cool drink, or an earth-friendly planting medium, coconuts truly epitomize nature's bounty turned into sustainable treasures.